Hello, Year 9. Today we're doing electron configuration. Now, this is kind of the last thing you need to learn before you can actually draw any atom that you're given. Because now you know how to calculate the numbers of protons, neutrons and electrons in an atom. And after today's lesson, you'll be able to draw the electron structure that surrounds the nucleus. So you will need your periodic table for this. So I'll take that, and here is the PowerPoint for today. Right, starter then, find sodium on your periodic table and calculate the number of protons, neutrons and electrons. So pause it, have a little go, and then unpause it. Okay, hopefully you've done that, so let's have a look. Where's sodium? There it is. Sodium is here. So let's go into PowerPoint. Sodium is 2311. So I always like to write pen, P-E-N. How many protons does sodium have? Well, that is to do with the number on the bottom. The proton number has 11, which means that it also has 11 electrons, because these two numbers are always the same. Then to work out the number of neutrons, we do the top number, take away the bottom, so there are 12 neutrons. So if sodium lost an electron, what would its overall charge be and why? Well, at the moment, these protons have a +1 charge and these electrons have a -1 charge. So right now they balance, right? So if I was to write it as a maths equation, I'd have +11 minus 11 equals 0. So that's a 0 charge. But what if I had lost 1 electron? Well, I'd have +11 protons, as in my charge of 1 proton is +1, so the charge of 11 protons is +11. But I've only got 10 electrons, so my overall charge would be +1. We call this an ion because now, overall, this has a charge. Okay. You've seen these diagrams like this before, and the nucleus is pretty straightforward. Now, you will be able to calculate the number of protons and neutrons in the nucleus, and they all just go in there. But the electrons orbit on electron shells, and they follow a very specific pattern. Now, the diagram that is on the page here, we know is a carbon atom, because this carbon atom has 6 protons, right? If it has 6 protons, it has to be carbon. Now, what happens is the shells have different energy levels, so the electrons orbit the nucleus at different energy levels, and they like to be at the lowest energy level possible. Now, the first shell is the lowest energy level. So if you have to add electrons to a diagram, you start at the lowest energy level and work your way out. Whereas if you have to take electrons away, which happens if something turns into an ion, you start at the outermost electron shell and work your way in. Now, here is the rule. The first shell can only hold 2 electrons, but every shell after that can hold 8. So, for example, lithium has 3 electrons. So, the 3 electrons, 2 of them will fit on the first shell, and 1 fits on the outermost shell. Boron has got 5 electrons. So, if you were to draw boron's electronic structure, 2 electrons would fit on the first shell, then you have 3 left. Those 3 would go on to the second shell. Argon has got 18 electrons. Okay, so 2 go on the first shell, 8 can fit on the second shell. That gives us a total of 10, and then we've got 8 left, and 8 will fit on the third shell. Notice how it is good to draw them in pairs like this. You don't have to do this. You can put the electrons anywhere on the shell that you want, but we draw them in pairs because it's easy to count. Okay, it makes it neat, easy to count. You're less likely to make a mistake, and when you go into A level, you will understand why electrons pair up. It's to do with one of their quantum properties. Now, notice if you look at the periodic table, lithium is in group 1, boron is in group 3, and argon is in group 0. The outermost electron shell tells you, sorry, I should say the number of electrons on the outermost electron shell tells you the group number of that element. So boron has got 3 electrons in its outer shell, so it's in group 3. Argon has a full outer shell, so it's in group 0. Now, so what we just covered there was elements in the same group have the same number of electrons. So anything that's in group 1 has 1 electron in its outer shell. So lithium, sodium, and potassium will all have 1 electron in their outer shell, but they will differ because they will have a different number of shells. Now, you need to be able to draw all of the electron shell diagrams and write all of the electron structures up to calcium. Now, before we go on, I'm going to do there's a little sort of trick you can use. So let's move this out of the way and get the periodic table up. Now, let's do a few examples. Let's say I want to draw the electron structure of maybe, we'll do lithium. We've done lithium actually. We'll do carbon. So if I want to do carbon, okay, carbon is 612. To work out the electron structure of carbon, you'd have to work out how many protons, electrons, and neutrons are there first. And luckily for this one, it's quite easy. It's just 6 of all of them. Then I know I've got 6 electrons. So what I would do is I draw the nucleus. I'm just going to draw a dot and put a C in the middle because it's just to save time. Now my first electron shell for carbon can only have 2 electrons. Because I've got 6 electrons, I'll just put the first 2 here and here. Okay. Now my second electron shell can hold 8 electrons, but I've only got 4 left. So 1, 2, 3, 4. And if you double check, you've got 6 crosses there, so that means you've got 6 electrons. So this is the electronic structure of carbon. There is another way to write that. This is called the shorthand notation. The electronic structure of carbon is 2, 4. What this says is I have 2 electrons on the first energy level and I've got 4 electrons on the second energy level. Now, remember when I said maybe 2 lessons ago, the group number tells you how many electrons are in that outer shell. So we should know that there are 4 electrons on the outer shell because carbon is in group 4, but we also said the period number tells you how many shells there are. Notice that carbon is on the second period. Okay, so we know that carbon has 2 shells. Now there is a little cheat way of figuring out how many electrons are in something. Okay. Now we know carbon has got this many electrons in because we've just done it, okay? But let's say I wasn't sure how many electrons carbon had, and I needed to figure it out, and my brain's gone completely blank and I've completely forgotten all the rules. So what I'm going to do is count along my periodic table, because we know that hydrogen has got 1 electron, helium's got 2, lithium's got 3, 4, etc., because of the way the periodic table is ordered. So this is my first electron shell. If I count this way, I know that carbon has got 1, 2 electrons in its first shell, and you keep counting up until you get to carbon. So in the second shell, I know it's got 1, 2, 3, 4 electrons in its second shell. This works for every single element. Say I wanted to do aluminium. Okay, so I'll change the color for aluminium, we'll do green. The electronic structure for aluminium is, well, 1, 2 electrons in its first shell, 1, 2, 3, 4, 5, 6, 7, 8 electrons in its second shell, and 1, 2, 3 electrons in its third shell. If you're struggling to remember the rule, because the rule is that it's 2, 8, 8, and so on, you count up, and that is exactly why we've arranged the periodic table like this. Okay, it's a very logical order, and it means that if you forget the rule, you just count up, just like I've just done there. So let's get rid of that. Okay, so let's continue with this. Now, what I want you to do, we'll get your periodic table ready. I'd like you to draw the electronic structure and write the shorthand notation for the electronic structure of helium. So pause it, have a go. Right, hopefully you've done that. Unpause, and here's your answer. Helium has 2 electrons, and the electronic structure is just drawn as a 2 in brackets because there's only 1 shell. Okay, so that is the shorthand notation. So the next one, sodium. Find sodium on your periodic table, draw the structure, and write the structure in shorthand notation. So pause it and then resume when you're ready. Okay, hopefully you've done that. Sodium has 2 electrons on the first shell, 8 on the second, and 1 on the third. Remember, sodium is a group 1, so it has 1 electron in its outer shell. The shorthand notation is 2, 8, 1. Right, do that for carbon, please. Hopefully you've paused it, you've drawn it, and now you're resuming. So here it is. Carbon's got 2 on the first shell and 4 on the second shell. And then the last one, I think, is chlorine. So again, pause, have a go. Hopefully you've done that, and you should have got 2 electrons on the first shell, 8 on the second, and 7 on the third. Oh, we're not quite done yet, we've got aluminium. So do it again, please. And you should have got 2, 8, and 3. If you have got the hang of this, you can start skipping them. I think calcium is actually the last one. Right, and you should have got 2, 8, 8, 2. Now this is the biggest one that you'll have to draw, and you'll notice that calcium is the last element before the transition metals, and the electronic structure goes a bit funky when you go through the transition metals, so we don't draw the structures of that because you will learn about it at A level. Okay, so what we're going to do, now that we've had a little bit of a practice drawing them, we're going to do, let me just get rid of this, a bit more practice. So the first worksheet says it's the Electron Config worksheet here. I'd like you to go through and draw the structures. Now, don't use the worksheet. I would draw the shells yourself. So, for example, if I was doing this, I would go hydrogen 1, 1. I'd draw the structure and put a little H in the middle. and then I'd say, well, I know hydrogen's got 1 electron. Then I'd do helium 2, 4. I would draw the structure because we know it's 1 shell, and I'd write He in the middle, and I know helium's got 2 electrons. That is going to be much easier than trying to put X's on that diagram. Okay, this works in the lesson because you get a nice big piece of paper, but for here, draw your own label, do them, and maybe do 1 or 2 from each row, or I should say 1 or 2 from each period, and if you're getting them right, you can stop. If you're struggling with them and you are getting them wrong, have another go, email me and I can give you a bit more assistance in doing it. If you've got a fancy tablet-y thing, you can actually draw it on here, but it might be a bit cramped. Okay, so if you've got something that you can draw on like that, you can do it on the paper, but it will be cramped. Now, this one, after you've done that first task, if you are absolutely fine and you are good at drawing the structures, you can stop. If you are just completely stuck, okay, this takes it up in stages. Skip activity 1 and go straight on to activity 2. What you can do is, if you're really struggling, you can look at the atom and see if you can identify which element it is. Now, for example, here I know this has got 1, 2, 3, 4, 1, 2, 3, 4, 5 electrons. So, which atom would have 5 electrons? Okay. And then once you've done activity 2, it might help you go back and do activity 1. Then once you've finished, the answers are on this bit here. And then once you've done that, you are done. So today's quite a quick one, but electron configurations are really important and you've got to get them completely nailed. So you've just got to practice and suddenly it will just click and be really easy. So after you've done that, email me your work and you're all sorted.